Hello and welcome to yet another video and welcome to Kirti's Learning Factory. Today we are going to learn a very interesting concept, which basically we are going to learn about remainders. Okay, and we are going to learn about the expression, the generic expression of remainders, how to find out remainders, and a few very basic fundamental things, which are basic, but then simultaneously they're also important. So let's jump into it. First concept is this. If there is a number n, okay, if there is a number n, it can only have remainders from 1 to n minus 1. Yeah, so this is the first principle of remainders, and it is very intuitive to think and think about it. So for example, say there is a number 3. Yeah, so 3 can only have remainders as 1 and 2. Which is, if number is 3, how many different remainders are possible? N minus 1. Okay, because obviously the moment the the next 3 comes, it will become completely divisible by 3. Yeah, so the number of possible remainders for 3 is 1 and 2. Similarly, if the number is 4, 1, 2 and 3 are the possible remainders. If the number is 5, 1, 2, 3, 4. Similarly, for 6, it is 1, 2, 3, 4, 5, right? So on and so forth. So net, what we have learned is that if there is a number which is n, the number of remainders possible is n minus 1. First thing to learn. Therefore, it brings us to the second concept. What is the second concept? The second concept is that any number, uh, when it has to be written, say, in form of, say, for example, there is a number 6. Oh, yeah. Now we have to express all the numbers in the number system, natural number system, in form of an expression of 6. So for example, there is a number which is divisible by 6. We can write that number as 6n. Then the next number will be 6n plus 1, correct? Therefore, this is the number when divided by 6 will leave a remainder of 1. Next number will be 6n plus 2. Next number will be 6n plus 3, 6n plus 4, 6n plus 5, and 6n plus 6. The moment we come to 6n plus 6, this is the next number, which is again totally divisible by 6. Yeah. So that is the way in which we can express it. Now, what happens to the numbers which are, uh, above this number 6n? These are the numbers which are after 6n. What are the numbers which are before 6n? Yeah, those numbers will be what? Those numbers we can write as, one second. Those numbers we can write as, yeah. So the numbers before 6n we can write as 6n minus 1, just before this. 6n minus 2, 6n minus 3, 6n minus 4, 6n minus 5. And the moment it comes to 6n minus 6, this is the number which is a multiple of 6, correct? Now, while here it is very, very clear that the remainders will be 1, 2, 3, 4, and 5. In this series, think about what will be the remainders. When we say the number is 6n minus 1, the remainder here is actually 5. The remainder here is actually 4. The remainder here is actually 3. The remainder here is 2. And the remainder here is 1. Which means that 6n minus 5, depending on the value of n, is basically nothing. It can be expressed as 6n plus 1. So these two are same expressions. Okay. So let me explain it by an example. There is a number 29. You divide it by 6. Yeah. And the remainder will be 5. Now the same number, say for example, So 29. 6 is the divisor. 6, 5 times is 30. Say we multiply 6 by 5. In that case, the remainder is -1. Same number 29, when we divide by 6 4 times, the remainder is 5. So basically 5 and -1, they are same remainders. What changes is the divisor, the factor. So which is why 6n plus 5 is equal to 6m minus 1. The value of n and m, of course, they will differ, but for some value, plus 5 remainder is equal to -1 remainder. And then it applies for all the other numbers also. So if you had to express everything as remainders of 7, so 7n is a multiple. Yeah. Next number will be 7n plus 1, then 7n plus 2, then 7n plus 3, then we have 7n plus 4. Okay. The next one is 7n plus 5, and the final one is 7n plus 6. So these are the 6 remainders, 1 to 6, which are iske pehle. Before that, we will get 7n minus 1. Then we will get 7n minus 2. We will get 7n minus 3. We will get 7n minus 4. We will get 7n minus 5. And we will get 7n minus 6. And then we will get 7n minus 7, which is nothing but a multiple of 7 itself. Yeah, so this is the multiple of 7. Yeah, and here 7n plus 7 is a multiple of 7. So, which is the number right after the multiple? It is 7n plus 1. Here, this is the, what is the number right before, right? Right before a multiple, it is 7n minus 6. So 7n minus 6, 7n minus 6 is the number here. It is nothing but 7n minus 1 is nothing but 7n plus 6. These two numbers are same. Similarly, 7n plus 2. 7n minus 5 is nothing but 7n plus 2. So 7n minus 6. Yeah. So minus 6 and plus 1. These are same remainders. Minus 5 and plus 2. These are same remainders. Minus 4 and plus 3. Same remainders. But what will only change? The value that will change. So when you arrange it, you will realize that because you are writing it by diminishing a number each from 7n, which is why you will get in negative here. Whereas here you are moving ahead in the number system. So when you are writing remainders, don't get confused, because very often then you will be asked questions on this, and this is a very fundamental way of expressing numbers as remainders. Yeah. So remember that these two principles are very, very important. If you enjoyed this, then come back for more such videos on my channel. And till then, keep watching. Thank you for watching again.